All right, let's look at the existence part of the proof. All right, so we want to show that 4x to the fifth plus x cubed plus 2x plus 1 equals 0 has a root, right? So we're going to do the exactly one part later. So let's do that. So let's review this intermediate value theorem, right? It states this: if a function is continuous on a closed interval from a to b, and the k is any number between f of a and f of b, then there exists some real number c, which is between a and b, such that if you plug in c into the function, you get this exact value k, right? So this is actually a pretty intuitive theorem, and if you look at the picture, it makes sense, right? So it goes like this. So remember that the f is continuous, right? So there's no breakage in the graph. All right, then it goes through, say, f of a. I'll just randomly put a point. So here's f of a here. So a comma f of a. So the graph has to go through that point. And f of b is, say, up here. So b comma f of b is up here, right? And f is a continuous function, so we have to go from this point to that point, without any breakage in between, right? So k is any number between f of a and f of b. So we'll just randomly pick a k to be something like somewhere over here. So here we have our k, right? So then you have, I'm going to just indicate, so this is the line y equals k, right? Then you can see that maybe I'll do a solid line so it doesn't have, so here's y equals k, right? Then function has to start from this point and ends that point. So no matter what you do, keeping it continuous, you can see that to go from one side to the other side of this line, you have to go through at least once to get to the other side. So this theorem ensures that there's going to be c, like this guy, exists, right? It makes sense, right? If you want to go from one side of the line to the other side, and unless you can jump, you're going to have to go through this line at least once. That's basically what the intermediate value theorem says. All right, so we're going to use this theorem to prove the existence of the root of this equation. All right, so let's do that. All right, first we have to name things to consistent with the notation here. So I'm going to let function f of x to be left hand side of this equation. So it's going to be 4 x to the fifth and plus x cubed plus 2x plus 1, right? And also we're going to set k value to be 0, which is the right hand side. So we're going to let say k to be 0, right? And since this f of x this is just a polynomial function of degree 5, so we know that it's differentiable, and of course it's continuous everywhere. So there's no problem satisfying this condition here. And here k, we set k to be 0, which is the right hand side, because we want the right hand side to be 0. And we have to make sure to find the a value and the b value, so that the k is going to fall between f of a and f of b, right? So k is 0, so we want to see, we want one of them to be positive and the other one to be negative, right? So easy one to do would be, I'm going to set, let's see, I'm going to do probably a to be -1, right? So you just have to find, say, a to be -1, so a equals -1, and let's try b to be 0. right? All right, so let's find f of a. So f of -1, right? So this is easy, right? Just plug it in. So we have -1 here, -1 to the 5th is -1, still times 4. So -4 plus -1 plus -2. So -4, -1, -5. So it's -7 plus 1. So it's -6, right? Which is definitely smaller than 0. All right. Then how about f of 0? Right, so this one is even easier. That's 0, that's 0, that's 0, it's 1. So this is going to be 1, which is bigger than 0, right? Which give us this condition. So if you set that, you know that f of -1 is less than 0, which is the k value. So this is the k value, and less than f of 0, right? So you can see that the 0 is between f of -1 and f of 0. Remember that -1 is a value, 0 is the b value. So you can see that here, since f is continuous everywhere, so there's no problem of verifying that f is continuous on interval from -1 to b0, right? And also we have this guy, so we just have to make sure we have, so f is continuous on this interval, so we got that. And the k is between f of a and f of b, so k is between f of -1 and f of 0, so we got that. So this function and the k equals 0 satisfies all the condition required for this theorem. So we can apply this theorem. So what does the theorem say? The theorem says that there exists, so by intermediate value theorem, we know that there exists C between -1 and 0 such that f of c is equal to k. So f of c is 4c to the 5th plus c cubed plus 2c plus 1 equals 0. Right? So which means that you can see that this, c is one of the root. So therefore, c is at least one root of the equation above. So I'll just say of the equation. All right. So we can prove the existence of the root using intermediate value theorem. So make sure that the function you set is going to satisfy these conditions. So f has to be a continuous function over these intervals. And the k value set, in this case 0, is between f of a and f of b. In this case, I pick a to be -1 and b to be 0. Just look for some value that makes one positive, one negative. Right? Then by the theorem, we know that there should be at least one real number c between a value and the b value, such that if you plug into this function, it's going to give you the k value, in this case 0, which gives you the root that we're looking for. Right? So this shows that we have at least one root for this equation. Right? That's it. I hope that this was clear.